And this is a Dutch scientist at the TU Delft, who's for quite a few years now working on what's called bioconcrete. And for those who don't know, these ones were early images, they look rather ugly there, but these ones are more recent ones. Bioconcrete is a sort of actually amazing discovery that certain cells who can live in these cracks eat the concrete, and the excrement of the cell creates a binding glue that can glue the concrete together again. So in the future, really, if they manage to manufacture this in terms of a product, it could be extraordinary that buildings that were made out of concrete in the 20th century might be healed back into the original state rather than enormously expensive refurbishments. I think this phenomenon is even more important. This is called a biobrick. And this is an American scientist sitting, an architect sitting at the University of Sharjah, Ginger Dozier, who is working with the scientists there. I was there recently, and I heard that she was actually in America trying to produce this on a large, mass-produced on a large scale. And her point is that brick, which is one of the most traditional building materials that you have, is one of the most polluting ones as well. You have over 1 trillion bricks being burned, produced and burned every year, and the greenhouse emissions are on an extraordinary scale. But in a sort of bizarre way, we think that when we see brick houses, we think that they are much more sustainable than other buildings. And in fact, the brick itself is a completely unsustainable material because of this burning process that it requires. The biobrick principle is that it doesn't have to be burned. It's like a coral. And the fact that she sits at the University of Sharjah with the scientists, material scientists and biologists is interesting because they have coral reefs. So they're looking into different corals and how this spongy-like material gradually grows until it has a certain shape. And then it sort of becomes a stiff hard material which has very strong properties. But as I said, growth is something tricky to control. It's easy to talk about it, but it's difficult to give it maintenance and stop it. But nonetheless, you have things like biomaterials or bioplastics that are interesting. They have sort of qualities that are biodegradable properties. And another one that is also coming from America is this new insulation material, which is done out of the waste product from carpentry. It's this wood waste, and the fungi grows into it and starts taking over as a binding material all these, is the English name? No, what is it called? It's the waste material, the thin powder from the carpenters. The sawdust. That was what I was looking for. The sawdust is bound. I need to be sort of living in the UK and come to Taiwan and ask the Chinese to tell me the English name. But the point what I want to make here is that there's nothing really chemical about this. There's nothing artificial. It's really to do with fungi growing, a certain type of fungi growing within the sawdust, binding it together. And when the fungi stops growing, they create these plates that have really good insulation properties.
So what is that? Sorry, we have to use Chinese to understand. So what is that? This is what Oh.
So the fungi grows into that powder that is the waste product from wood, what the carpenters do when they cut the wood. And that wood is then bound, not with a glue, but with a fungi. And it's amazingly resistant. We had a student of ours who got one of these pieces from this company in America. And we were sort of 16 people looking around in sort of fascination of how interesting the material was. When he then wanted to do a model 2 weeks later, the material was completely bent. Because the fungi obviously reacts to the moisture of the air. So he realized actually the fungi was not completely dead, it still was sort of alive. But you can see here that they're really starting to produce it on a larger scale and mass production. I mentioned Francois Roche before because I think Francois Roche is indeed interesting because he's trying to cover two fields that are not necessarily always related, which is the the idea of biomaterials and computational processes. So here you have a few studies of corn-based material, and the different tests of the corn, on this corn-based composite, was then 3D CNC milled, and by extracting the material through a computational model, he created this sort of rather complex wall. And then these tip points here have sprinklers, which were moisturizing this corn-based composite, so that the wall was gradually getting degraded. And in a way, this statement was that architecture always thought about a sense of timelessness, of eternity, that it can stay forever. But in fact, if you look at biomaterials, there's a level of limitation of time. It might get degraded. There's a vulnerability of the material. And that brings us back to a sort of more existential sense that all this new nature-related thinking brings to us. We had a student of ours, Richard Beckett, who was actually teaching with us, who took this idea of the corn-based components and iterated them through a script on a wall and proposed this wall to be built. He's still working on that, actually, to build it as a larger scale prototype so that the vegetation gradually takes over. And similar to the triptych case in Brazil, you just let it happen. You don't have to treat it. You don't want the wall to look always the same. With birds and insects and the whole fauna and botanic diversity, it will sort of take its own rules and create that sort of wall. This was a very recent project, and I showed only this image because I find it really a first step of something. This student was looking at a sloth. You see this animal down there? The sloth is an animal that lives in, I think, mainly in South America, and moves very, very, very slowly. It sort of likes living upside down, hanging from a tree. There are no sloths in Taiwan, are there? Does it exist here in Taiwan, the sloth? It's in Portuguese and Spanish, it's called the lazy. I went with my daughters to see the sloth at the London Zoo, and it was the most boring thing you can imagine. The daughters were very bored because it doesn't move. It's there for hours. It wasn't even eating, but the eating process takes hours. So anyway, the thing is that the sloth moves very little because it's a very skinny animal. Very thin, skinny animal.
How large?
It's about this size.
Huge.
Yeah, it's bigger. It looks like a monkey, basically. But it's not of the family of monkeys. But what is special about it, it's covered with fur. The fur is very long, and the fur is full of algae, because it lives in the rainforest, and the moisture of the air and the dripping of water makes the fur to be full of algae, and it has, in fact, hundreds of insects that live in the fur. There's even a moth that exists only in the fur of the sloth. So this is an ecosystem in its own right. This animal carries around a complete ecosystem. No wonder that it moves so slowly, because there's a lot of weight to carry around. It's a small rainforest in its own right. What the student was looking at was an architectural construct which moves slowly as well. And if you think about the banyan tree, when the trees grow big and they are next to pavements, they completely destroy the pavements. They destroy houses, they destroy anything, because the roots become strong and bend anything. And what she was thinking about was that if vegetation is growing, it probably needs to be inserted in something where these ceramic tiles have joints, and they gradually adjust to the growth forces of nature. So rather than having a tiled system that is orthogonal, or what triptych and others people have done, which is to introduce small pockets of earth. These ones are much larger chunks of earth with the vegetation growing into it, and the expectation is the building will deform gradually and adapt to the forces of the growth patterns. She was obviously looking at also the computational sort of scripts that were creating these different tiled components, and in fact also manufacturing tiles with ceramics. And ceramics is a sort of new theme that in terms of materials a lot of architects are looking at. It leads me quickly to another topic, which is to do with the representation problem. When you think about growth in nature, we architects don't really know how to draw stuff that grows. Because our traditional drawings don't work, they're static. They're really to do with something that maybe flips and opens, but it doesn't have a process of growth in it. And this student's work, which I show quite often, which I really love because it's quite provocative, was the idea that you need probably to combine different codes. So she was looking at the way in which biologists draw growth and explain their principles of nature. She was looking at how chemists draw and think about the materials and how architects do. So the drawings became gradually sort of the mixture of chemical charts with biological drawings and architectural drawings. And this gradually was constructing this idea of an architecture. This, I think, is sort of an interesting point as a starting point for other attempts that should be made, because she was able at the time with her technical tutors to talk to biologists and chemists at the same time, because they understood what was there. Whereas when she went there with her architectural drawings, they did not understand. There was a problem of codification and language. Obviously, there are many different other ways. Colton MacDonald with Arab have been working on these sort of minimal surfaces and endless iterations of geometry that can absorb levels of water and insulation from the sun. So these permutations of geometry are definitely part of some of the ways in which we try to represent these things. You get Ecotech and other software that environmental engineers are using, real flow, sort of simulation tools in order to allow to understand when something is in flow. Up there's more traditional diagrams of a bioreactor. And here, sort of you get a range of things. This is what called the section of the green walls. This is a diagram of François Roche of the House of Paris, the Colton MacDonald studies with Arab, and then simulating software of growth patterns that are more and more available. Here, this was another student of ours simulating these growth patterns of vegetation. And then a lot of these other sort of more analytical tools to understand the air flows and the environmental conditions around us. This is sort of a quick array of different manners in which we are trying to embrace that something around us is much more alive than what we thought. It means it's much more in constant flux and change. It's not of a static nature. In 2008, I edited with Steve Hyde this AD called Neoplasmatic Design, and at the time it was an attempt to bring together quite a few attempts that had been done until then. And the attempts were all to do with architects and some artists who looked into biomaterials and biological matter, which was alive, as new architectural materials. So rather than looking at it as an analogy, it was to really to do with how do we design when something is alive. But this is now a few years ago, so sort of in a way new ADs came out and there's probably time to produce a new one. I think there is an impact of all these things on a larger scale. There's a lot being discussed about urban farming and new green paradigms in cities. These are two students of ours who did this design for Taipei when we visited Taiwan 2 years ago. And the whole challenge was about Taipei being one of these cities where water can't be absorbed by the ground anymore because it has so much of a concrete surface and tarmac surface that there is an imperviousness of the ground. And because there was a very strong agricultural tradition that preceded Taipei, there was initially a lake, then the paddy fields, and now it's basically the city taking over the whole of the valley. The idea was to bring in a new irrigation system. So you can see here, this is sort of a new irrigation system of water, and these algae farms that could become a new type of urban agricultural system, which could take people away from the traditional mechanisms of agriculture that really embrace new, more sophisticated technologies. And potentially also ecologies, because these ones could become new ecologies in their own right. I show this image because this is sort of Paul Le Corbusier with his Plan Voisin. And his ideal vision of the city which detaches buildings and the architecture from the green. The fantasy of this time was all to do with this separation and the possibility that we could look from the distance at nature. By giving nature more relevance, we were not touching it, sitting on the balcony and just enjoying the beauty of it, but clearly keeping them completely separate. I think more contemporary trends are really trying to merge them. This is a project of ours for Taipei, some towers where the green area of the gardens here and the facades are sort of trying to be merged together. And now I show you a few images of projects. When you Google green architecture, you get sort of 1,500 different images of projects that all have to do with green stuff, green growth on their facades. This is a project in Mexico, which looks like a pyramid. Bizarrely, you can get any shape now, any shape with growth on it, and it sort of goes. This is sort of in the Mexican rainforest. NPR&V have been big drivers on this topic with this project in Seoul, which they want for a competition, is an interesting case. This is another of the projects where the building even disappears. It becomes a piece of landscape. The whole luxury resort that they're proposing here is so much covered with nature that it really turns into a piece of landscape. And back to this case of Taipei, where really the facade and the garden, with a very careful control of what sort of vegetation could grow, would create this transition. Ken Yang is a very important case. In fact, I admire his studies more and more because he lives and works in Malaysia, and a lot of the projects he's producing are for a subtropical, tropical environment. And in fact, this green paradigm works in the tropics. It doesn't really work when you get to the UK. And so, as I mentioned before, I think the sense of what environment and what climate you have around you is absolutely essential to understand how you're playing with this topic. These are sort of, this is a project, one of many that he has proposed. This is one done by Stefano Boeri in Milan. Now, that will be interesting to see. These towers are being built right now while we are talking. They're building them. They're going to be pretty tall, I think 50-story towers in the center of Milan, covered with trees. Whether they will ever work, I'm not sure, but we're here to see. NVRDV again with a whole set of green roofs. Now what is interesting to observe is when you look at the so-called green architecture, these buildings that introduce plants in their own physical substance in order to control the environment and to turn it into a more green environment. Many of them are also skyscrapers. And that's interesting. This is clearly at the moment of our times when after ground zero, where we're saying the skyscraper is dead, there was a complete mistake. The skyscrapers are more alive than ever. Everybody's building towers more than ever. And so the green paradigm in the vertical city is starting to become merged. They're becoming actually one. And studios like NVRDV are sort of big drivers of that. You get sort of towers in Beijing and other cities in Chongqing, etc., with lots of green roofs. I'm not sure whether 150 or 200 meters above the ground, that tree up there will be growing. But again, we are here to see, and we sort of enjoy the fact that at least there is this positive thinking that in my mind. Mad Studio with this tower for one of these Chinese cities, I think in Chongqing. Again, similar issue. Quite wonderful here, but what the hell is going to happen there when the winds are strong and the climate is very different up there? And Mad Studio again. Korean studio with these completely covered green buildings and some other projects for Hong Kong. On a more serious level, really, and less speculative, what quite a few architects are trying with biologists is to carefully control what can be actually grown in these towers. And this is one of these examples where there's sort of careful description, where sort of the tomatoes can grow, or the peaches and the lettuce in the green towers. And what I find actually really relevant is not so much that you can go into the tower, but it's the fact that in it implies another new topic, which is of great importance, which is food. In my opinion, the future of these new ecologies in architecture are really to do with the notion of energy, environment, and food. And we cannot exclude food. And it's no coincidence, for instance, that one of the three big priorities of research of the United Kingdom is food shortage. So any project in the United Kingdom that is dealing with food will be sponsored by the government, because food shortage is one of the great risks and problems we are going to face in the future with the growing population. And when you look at smaller scales, food production is being thought on many different levels. Here you get sort of hydroponics on these rotating components that can be inserted in buildings, where you could have the production of lettuce for a whole building. So the fact that there's a sort of optimization of exposure to light, the lettuce can be grown, the vegetables can be grown for a whole building, these are thoughts that are being already discussed and tested. You get sort of more radical cases like the new fridges of veggies. Sort of, you might be going now to, what's the big Japanese shopping mall here called, a very big one? The Mitsukoshi. We'll be going to Mitsukoshi in a few years' time, and we'll go to the electronics department and you get sort of your veggie fridge. And the kitchens might need to be rather big, but basically the point is that these companies are really trying to consider what it means to start growing stuff within your house. And within these incubators, which are these very carefully controlled environmental fridges that can grow the fresh vegetables that you're going to use for your own consumption. And you even go further to kitchen furniture. It's sort of becoming really extraordinary that the kitchen companies that produce kitchen tables are thinking about those tables which are going to be used to produce the food and prepare it, but also to produce the plants and the ingredients for that food. So this is becoming a conjoined system. And I mention this because this is on a much smaller objectual scale. So the object, the furniture, is being thought of as much as cities on a larger scale. And the most sort of known case of the urban farms, which is a big pervasive phenomenon in many cities in the world. It's clearly something that started in the post-war era in sort of the European towns like Berlin and Vienna, where you had the Kleingarten, which are small urban farms where people grow their sort of 10 potatoes, 3 lettuces, and 2 apple trees. And in fact also be able to get out of the intensity of the city. But that is becoming a gradual trend. So I think the rethinking, shifting of our mindset from the kitchen table through the building and its facade down to the city on a larger scale, covering the energy, environmental and food consumption is a very broad picture that we have to sort of look at. Through obviously the influence of biomaterials, the materials that are being produced more biologically. I get to an end because I wanted to allow a bit of time maybe to have a conversation, which is a project that Maren and I did a while ago, but we're still sort of looking into developing this further, which is to look at the larger scale of food production and these irrigation circles. And if you think that the first settlements of mankind have been after the early societies, being hunters who were running around behind animals, the first time when they created settlements was when they managed to produce food. And the production of food was when agricultural in its primitive form started emerging. So the production of food started creating geometries and grids on the landscape in order to produce in a more organized and efficient manner the crops. And it was around these crops, in the middle of them, that the first settlements of people started emerging. The villages in nowadays still are intricately related to the patterns of landscape and the irrigation systems that exist. So the supply of water, the type of soil, and the geometry, the implicit geometry of the landscape influenced in a way the basic organization of settlements. And But along these lines, we were looking at these irrigation circles, which started in America and are now in the Middle East everywhere, in very deserted, dry areas where there's no water supply. The water comes from these central wells. The wells are very deep. They go to the aquifers, and they extract the water from very deep up to the surface and distribute it in a very efficient, homogeneous way for the agricultural land, which is around the surface. But our thought was that if we take this principle, then this is an implicit geometry that allows maybe in the interstitial areas to start growing cities. So we call this the new agro-city. The agricultural city is the city that grows around these big circles of agriculture, where the production is being controlled by new settlements, which have a much higher level of environmental sophistication as buildings, but then gradually in between them, more buildings start to merge. But a lot of it relates to the production of food, which is done locally for the local population. And as much as the buildings then grow, they gradually start sort of taking over the interstitial areas and occupying the land in this constant relationship. I'm not sure whether in Taiwan this is a phenomenon, but in the UK, in big cities, it's all about locally produced food. It's becoming the biggest trend. If you go to the markets are all about the potatoes and the carrots that have been produced only 2 miles far away. And if you buy honey, which is honey made in London, even better. Whether it's environmentally that sustainable is still worth a question, but it's a phenomenon, it's a trend. Because we know that if you take the tomatoes that are coming from somewhere South America, the level of energy consumption just to bring it on a ship or an airplane is just absurd. So clearly our attempt here in a longer term research project is to look at manners in which the irrigation circles in dry areas could create the underlying pattern for an immediacy of food production, but also of green areas that produce good environments, but also on a smaller scale could create squares, so the whole city becomes much more of a growing interstitial system. I mentioned algae before, because algae is by far the most important product that anybody who's dealing with this stuff is dealing with. So if I mentioned also grass before, and I think grass is sort of a bit of a parody. People are using grass because they're sort of obsessed with green. Algae there's much more depth to it. There are lots of research departments where algae is being researched into the basic material that can produce food, also the basic material that can create biofuel, so it means it can create energy, and on a much smaller scale, it could create through its photosynthesis directly energy itself. This is the English company MADE, which with Max Fordham, which is an environmental consultant, working for a few years on algae tubes that could cover whole buildings. So the thought is that there's so much of a surface that buildings are potentially exposing to sun, that if you use those facades to produce algae on a larger quantity, you could create the best biofuel plants in cities. And there's a lot of carbon dioxide in cities as well, so the algae will be constantly stimulated by this carbon dioxide production. There is a lamp, the lateral lamp, that is designed by a Dutch artist, who's this fantastic thing. You arrive at home, you have your lamp there, there's no light in it. The poor algae need a bit of carbon dioxide. You breathe your air into it, like that. And after a while, the algae becomes stimulated because of the carbon dioxide, and the light starts glowing. He has experimented with this already. This already exists. There's obviously a time issue. I'm not sure that this works so quickly as we imagine. But the simple thought that your own breath can stimulate algae that is producing light, I think is fantastic. In fact, some researchers at the University of Cambridge are working on tables that are embedded with algae, very specific algae, where the current is coming from this photosynthesis directly into the lamp. So no need for energy. And I just want to quote Rainer Banner. I'm not sure how known he is here, but he's a famous historian of the 20th century, who in one of his books, The Architecture of the Well-Tempered Environment, spoke about electric light. He says that the supply of private electric light in our cities was probably the greatest environmental revolution in human history since the domestication of fire.